Hi, I'm Ian, a developer relations engineer at Google DeepMind. And in this video, I'm going to talk to you about the concept of hybrid LLMs and how you can get the best of both worlds, combining an on-device LLM with a cloud-based one. So before we dive in, let's all get on the same page. There are a few things we could mean by a hybrid LLM architecture. So here's the definition that I'm going to use. A hybrid LLM architecture is where we strategically distribute components such as language models, data sources, and processing tools across different devices and servers to optimize for performance, privacy, and model capabilities. In this video, I'm going to talk about how we can use Gemini, Google's family of cloud-based multimodal models, with Gemma, Google's family of open models, capable of running on a device with only a single GPU. So why might you want to deploy this architecture? Well, you might want to take advantage of local compute resources for certain simple tasks, but need to accomplish more compute-intensive tasks, such as reasoning or processing of large data sources in the cloud. You might have an application that needs to use the power of multimodal models offline, or perhaps you need to operate on data that can't leave the local device. Let's take the Gemma 3 family of models. It is now possible to run the 1B and 4B sizes of model on mobile phones, tablets, and laptops with acceleration, while still retaining the capabilities of models that require much more RAM and processing to operate. This is possible today thanks to advancements in model architecture as well as improvements in device capabilities. So let's look at the following examples. There are many options, such as sequential architecture, where the on-device LLM reasons about a task before deciding whether it should go to the cloud model, or parallel architecture, where both models reason about a given task before merging their responses. Today, we're going to talk in more detail about routing architecture, where we train a text classifier to help make quick decisions about whether to route a given query to an on-device or cloud-based model. In this example, we're going to use the Gemma 3 1 billion parameters as our on-device model. It will neatly balance performance and capability on mobile devices. We'll use Gemini 2.5 Pro as our cloud-based model for reasoning and real-time data access. For the router, we'll use Mobile BERT, a text classifier optimized to run on mobile hardware. To illustrate how this works, let's imagine a simple weather app. The app's job is to answer questions about the weather. First, we will train the BERT-based router to label users' queries as either local or remote. We can do this by providing a few thousand pre-labeled queries that we have synthesized using the Gemma 3 27B model. Next, we will configure our app to look at the label before choosing to send it to the local model or the remote model. The app will then send the query to that model, which can be configured to use RAG, or a tool such as Google Search, or an API call to ensure that more accurate responses are given. We can then show the response to the user to answer their question. Now, evaluation for the success of both the router and the responses from the LLM is key. You will want to make sure you factor in quality, latency, and labeling outcome to ensure that your app is optimized for your use case. So there you have it. You really can have the best of both Gemini and Gemma with a hybrid LLM architecture. Take a look in the description below for more resources for building your own solution. Stay tuned for more AI content, and as always, we look forward to seeing what you will build with Gemini and Gemma.